Okay, so for the hiker going on the hill like this, you said that they have a 9% slope here, right? Is that right?
Yep.
Okay. So that means that this part could be, say, 9 meters, and this part could be 100 meters. Okay. So this is going to allow you to get the angle right there. Okay. Now, if a hiker were to go across here and it were totally flat, it would take 380 watts of power to go at that rate. So as they, every second they're going to be using 380 joules of power. Okay. And what velocity did you have for your runner? 5 kilometers per hour. So I'll just say 5 kilometers per hour. Let me see. Okay, so their total power is going to equal 380 watts plus 4 times mg times delta y divided by delta t. Okay, so what is this part here? M times g times delta y. Where does that part come from? So this is the solution, but I want you guys to understand where all this stuff is coming from. So that's basically their the change in potential energy, right? So yeah, that's their change in potential energy. Okay, so that's how much energy it's going to take to move up a certain height. Okay, then why do we have the 4 right here? So the 4 here is because humans are only about 25% efficient. Okay, so that means that if it takes mg times h to increase your potential energy, okay, then that means that a human has to do 4 times that in order to increase in your height. Okay, so since we're only 25% efficient, then we have to do 25 times that. Okay. Now, we also have delta y times delta t, and we're going to say that this is equal to our velocity. Okay. So that's their.
Could you?
Okay.
Okay, thank you.
Okay, so that's going to be our velocity. Okay, and so here in this term here, we're going to have 4 mg times v. Okay, and that is our that's our velocity if you're traveling, say, in the x direction, right? So this is our velocity. We know that she's going this way, 5 kilometers per hour, okay? But this is the velocity that she's going up. So how do what we need is the velocity that she's moving up. So we know that on our triangle here, okay, this is our velocity this way. How could we get the velocity where she's going up? So this is her x velocity, but we need her y velocity. So we've got let's draw another triangle over here. So here's our triangle. We know this velocity, this is her Vx velocity, but we want to get her Vy velocity. So what could we put in there? If we know Vx, we want to get Vy, and here's our angle theta. Okay. Then which trig identity? Oh wait, I'm not showing the triangle. Oh man, I'm so sorry. I don't know what's wrong with me today. So this is our triangle. This is our x velocity, but we want her y velocity. Okay. So let's see. If we say tan theta is equal to Vy over Vx. Okay. Then we can say, all right, we can substitute in for her Vy velocity. So we'll say Vy equals Vx tangent of theta. And you're going to have to figure out what theta is, but you can do that from the incline. So you can set in numbers there. On mine. Well, you could use these numbers up here to get the angle. So if you had a 9% incline, then you could get your angle from that triangle right there. Does that help, or am I just making it worse? So the metabolic power would be her total 380 watts plus this 4 times mg delta y over delta t, but delta y over delta t, that's her y velocity. So now we can write 380 watts plus 4 times mg Vy, okay? And we know what Vy is. Vy is equal to Vx times tangent of theta.
Thank you, like and subscribe down below.